let's talk about polygons, diagonals, and angles. Very important, of course, you know what a quadrilateral is, four-sided shape. We have triangles, three-sided shapes. And then we have, let's say, a pentagon, for example. You have a pentagon, five sides, right? And you have a hexagon and so on and so forth. The important thing to keep in mind is that these shapes have a certain amount of the angles will add up to something, right? So for example, you know that the triangle add up to 180 degrees. Did you know for a rectangle it's 360 degrees? Is there a pattern to this? Is there some formula that you should know to find the number of degrees? Well, it is n minus 2 times 180. That will tell you the sum of angles of a polygon. So notice with a triangle, 3 minus 2 times 180 equals 1 times 180, which is equal to 180. If I did four-sided shape, right, 4 minus 2 times 180, which is equal to 2 times 180, which is equal to 360. What if you have 5? 5 minus 2 times 180, and the rest, you see the pattern. I keep changing depending on what n is. This was n was 3, n is 4, and n is 5, right? Those are the different aspects to keep in mind. So we've looked at the formula n minus 2 times 180, right? If you're looking for just one angle, you divide it by n. So imagine if you have 3 minus 2 times 180 divided by 3, right? So then that would become, in this case, 180 divided by 3, so that's 60. If it's a regular shape, so a regular triangle or regular polygon where you have all the sides being equal, that is how you find the size of one specific angle, right? That's very important to keep in mind. But just remember n minus 2 times 180. But what if I ask you how many diagonals a shape has, right? These are consecutive sides. So you have like this one I just drew. From here to there is a diagonal, right? From here to there is a diagonal. What is the formula I could use for dealing with diagonals of a polygon? Is that a formula that I should know? I would highly recommend it. So you can try and count it, but what if I give you a shape that has so many sides? You don't want to waste time counting. So let's talk about a formula for that one. N times n minus 3 over 2 will be what you're looking for, right? So imagine you have four sides. So then you have 4 into 4 minus 3 over 2. So this 2 goes in here 2 times, and 4 minus 3 is 1, so that becomes 2 times 1, which is 2. There are only 2 diagonals, right, for that shape. So we keep that in perspective, that you take the number of sides you have, you multiply it by n minus 3 and divide it by 2. What if you have a pentagon? You do 5 into 5 minus 3 over 2. What if you have a hexagon? You do 6 into 6 minus 3 over 2, and so on and so forth. That is how we find the number of diagonals of a polygon. We can use that formula. For example, you think of shapes like a hexagon, right? And you want to find out how many diagonals, or an octagon where you have 8 sides. So you have 8 minus 3 times 8 over 2. And you find out there's 20 diagonals with an octagon. In a hexagon, there's 9 diagonals. And you can play with this later on, but just wanted you to keep that in mind, that there is a formula to find the number of diagonals in a regular polygon. Let's try one more example of an interesting scenario, adding up all that we've learned so far with angles and with polygons and so on and so forth. So imagine that you have a shape, right? Imagine you have this shape that looks like this, right? Imagine you have this hexagon, and again, we can find the sum of angles of a hexagon. So we can basically say n minus 2 times 180, right? So that's 6 minus 2 times 180. By the way, if you're just curious with the names, we had triangle, we had quadrilateral, we had pentagon, right? If you know your U.S. History and geography and so on, you know that there is a building called a pentagon, right? So it's 5 sides. You have your hexagon, you have your heptagon, you have your octagon, you have a nonagon, decagon. All right, so you have different, each one here, you have 3, 4, 5, 6, 7, 8, 9, 10. It's just fun to know. Now, if we look at this shape, and we can find 6 minus 2 times 180, so we have 4 times 180, so we have 720 degrees. We divide that by 6, we get 120 degrees for each one of these, okay? Now imagine if I asked you what is the measure of this angle, right? Like the outer part, like if I call that x degrees. Well, what is the angle of the point? It's 360 degrees, right? So you just subtract 120 from it. Do you see? You get 240. So x is 240 degrees. So that's what you need to do. You basically find the outer one here will be 240 and the inner one here will be 120. That is one way to do it. But notice before we found this outer one, we found these ones first using our formula n minus 2 times 180 over n being 6 sides, right, for the hexagon. Let me know if you have any other questions with the diagonals or the angles of a polygon, but that's what you would need to do for something like that, right? It's one way you can deal with those problems. Keep up the good work and have a great day.